Hey, what's going on, guys? Today we're going to do some solutions. I had a couple of requests for certain questions, and we're going to go over some geometry question that was posted last week, a couple of weeks ago. And I had a request for this complex question over here. So we're going to go over these questions. And first off, a question like this is tricky, because it has two ways of solving it. You could go deep down and try to solve the equation of the circle intersecting with the equation for all of these four choices, and it'll just be inherently complex. I mean, one way to do that would be the equation of the circle would be x squared. The center is 1 and 2. So the equation of the circle would be x minus 1 squared plus y minus 2 squared equals 1, because it's unit radius. So we could do that, and then try to solve for all of these choices here, and we'll take like 30 minutes or so. And we don't want that on a test. And a question like this might show up on a SAT 2. It might not show up on a SAT 1, but it could be a SAT 2 or academic decathlon or IITs. They would put a question like this, and you have to solve it really quickly. So one way to solve this would be what I was suggesting, the long method, which you don't want to do. Of course, you can get the solution, and you'll see which quadratic equation gives you the answer that is only 1 point, because as you can see, it's only intersecting at 1 point, so the line is a tangent. So we have to find out which one of these lines is a tangent to the circle. So how can we determine that really quickly? One way to do that is to find this distance right here. If it's equal to the radius, then the line is a tangent. So that's the meaning of exactly 1 point. Exactly 1 point meaning this is a tangent. So we have to determine how quickly we can determine which of these lines is a tangent is by finding the distance from the center. So now there's a formula for finding the distance from the point to the line. It's quite a simple formula to remember, and it's basically this. Now you can prove this by Pythagoras, and you can prove that distance from a point to a line. You could take a simple case like so, like you have an equation and this is a point. You can find this distance by equating the area calculated from two ways. This is your x, this is your y, and then you can calculate this distance times this altitude, or x times y half. So you could prove that really quickly. The distance of this will be the hypotenuse, which should be x squared plus y squared times half of the distance. So you could try to find it that way. The other way to find this formula is using a perpendicular equation of this line. It's perpendicular to the tangent and passes to the center. So if you have a line with an equation ax plus by plus c equals 0, we know the slope of the line is negative a over b. That's your slope. So a line that is perpendicular to the tangent, or any line, will have a slope that would be b over a. So something to remember, that slope of a perpendicular line is negative 1 over m. So if you have a line y equals mx plus c, a line perpendicular to that will have a slope of this. So that's another way to do it. So we find the equation of the line that is perpendicular to this line, and the slope would be y equals b over a x. And to find the c part, you just have to plug in these values, because the perpendicular is passing through that that point, the center of the circle. So you could plug that in here and you would get the value of C. So that way, that's another way of doing this question to find the distance. But we're going to go with the quickest way. It's a simple formula to remember is that that's your distance. No matter which method you use, you're going to come up with this distance that is going to be that. So let me give one more case, okay? So you have a line, ax plus by plus c equals 0. So let's quickly find out the intercepts. So we plug in x equals 0 to get the y-intercept. So y-intercept will be negative c over b. Just double check that. And the x-intercept, you put y equals 0, and you would run with negative c over a. Let's double check there real quick. Okay. So then we can find this distance, right? And that will come up to be, because it's passing through line 0, 0, the slope of the line would be y equals, slope of the line that is perpendicular will be AB x. Now it's passing through 0, so that will be your equation. So now we can plug this in and get the value of d, and that will get you an answer that will be something like this: c divided by a squared plus b squared. Okay, so without further ado, we're going to plug in these values in the formula quickly. So let's assume that we know that formula, and we're in a time crunch, and we got to go right into it. So then we can start plugging in the values in here. So 3 times 1 plus 4 times 2. Well, we're on a clock here. Minus 6 divided by 3 squared plus 4 squared. So we know that this is Pythagorean triplets. So bottom will be 5. Top it's 8 plus 3, 11 minus 6, 5. So right off the bat, we see that the distance of this right here comes up to 1. And that's our answer. That is our answer because circles has a unit radius. So the distance from this line to the point is 1. So you see about 10 to 15 seconds, you got the answer if you know the formula. If you don't know the formula, then it could be a little longer, but it's nothing that you can't derive yourself with a little bit of work. So that. So whether you remember the formula ax0 plus by0 plus c modulus, meaning negative or positive. If you get a negative value, we convert that to positive. A squared plus b squared. So whether you remember this or you remember c a squared plus b squared. Okay. That's the distance from the point 0, 0. And this is the distance from point x0, y0. So even if you remember the simple formula that is c a squared plus b squared from 0, 0, you can transpose the graph and shift the origin to x naught, y naught, and then you can convert these equations into a shifted origin format to get the answer. So if you really don't know the formula, the easiest method to approach that would be the tangent method. I'm assuming you would know at this point, if you're about to take a test like IIT or SAT, you would know the slope of a perpendicular line is negative 1 over m at this point. So the slope of the line, this, is negative 3 over 4. So the slope of the line perpendicular would be 4 by 3. So 4 by 3 plus c. So let's plug in because the line passes through 1, 2. So x equals 1, 4 by 3. And y equals 2. Okay, so we get the value of C, 2 minus 4 by 3. Okay. So we get the value of C. Let's double check this real quick. We plug in the value, 4 over 3 will be the slope of this line, because it's the reverse of the slope with a negative sign, and C passing through 1, 2, passing through 1, 2, and 2 minus 4 by 3. Yep. So the value of C comes to be this. So now we know that the equation of this line is y equals 4 by 3x plus 2 by 3. Now, this point right here, this point, is a solution of the intersection point of the original line with this line. So now that we know the equation, we can find out the intersection point and then take the distance. So let's just try that. We'll try the longer method. And now that we have the value of the equation, we're going to solve it. Now we already have the answer, but I'm just showing you, if you don't know the formula, you don't have to be stuck. It's just going to take you like maybe 10 minutes more, but you will get the answer right. So that's to me, that's worth it to spend 10 minutes. If you don't know the formula, you just derive the formula intuitively. So let's just try this out. So 3x plus 4y minus 6 equals 0. So we're going to plug in the value of y from here. So that will turn into 3x plus 4, and then 4 by 3 x plus 2 by 3 minus 6 equals 0. 3x plus 16x by 3 plus 8 by 3. Yep. Minus 6 equals 0. So we calculate the value of x, 3, 9x plus 16x plus 8 by 3 minus 6 equals 0. So we get 25x over 3 plus 8 by 3 over 6. What is that? Minus 18 equals 0. So that will become 10. So 25x by 3 plus, well, that will become minus, so this sign will be minus 3 equals 0. So 25x equals 10. So x equals 10 over 25. So reducing that to the ratio, 2 by 5. So we now know that the x-coordinate of this is 2 by 5. So let's plug that in here and find out what the y-coordinate is. So we get the y-coordinate by plugging this in here. So let's just clear this for a little bit. So 3x. Now the value of x we can substitute in here. 2 by 5 plus 4y minus 6 equals 0. So that would be 6 multiplying this whole thing by 5 plus 20y minus 30 equals 0. So 20y equals 30 goes on that side, it's positive. And then minus 6 will be 24. So y equals 24 over 20. This would be dividing by 4, 5, 6 over 5. So these coordinates, the distance that comes is 2, 5, 6, 5. And now we can calculate the distance from point 1, 2 and see that if it gives us the value of the radius. So 2 minus 6 by 5 square plus 1 minus 2 by 5. Yep, that's correct. So n minus 6 squared plus 3 pi 5 squared. So it's 4 squared by 5 squared plus 3 squared by 5 squared. Now we're looking at the triplets. So you add this together, 4 squared plus 3 squared equals 5 squared. So in the end, no matter what method we use, whether we know the formula or we don't know the formula, we can still calculate that the distance is coming as 1. So if the distance is equal to the radius of the circle, that means the line is a tangent. So I kind of wanted to show a full method, all different ways to doing this problem. But ideally, you would want to know the formula for a distance between a point to a line, and that's something really handy to remember because you will run into several different questions where you have to quickly get to the distance between a line and a point or a line to the graph, and then you need to be able to know that. Anyway, so we're going to go over to the next question, which is the calculus question. And it actually isn't a calculus question. It is a componendo and dividendo question. Might show up on IITs or ACTs or SAT2s or decathlons. Might not show up on SAT 1s because it is a little bit more complex, but it is not hard. So to simplify this function, it looks very daunting per se, but what we're looking at here is e to the power x plus 6 plus e to the power x minus 6 divided by e to the power x plus 6 minus e to the power x minus 6. Okay, so that's your fx/gx part. Plus we have this complex, let's just call it subfunction zi. Okay, we're running out of room. So this needs to be equal to 0. So if we were to apply componendo and dividendo in here, you can notice that this cancels out. Okay, if we add the numerator and denominator together, so componendo and dividendo is a b equals c over d, which means a plus b, a minus b equals c plus d, c minus d. So we're going to apply this rule. It's also pretty easy to prove. I'll show you. I'll demonstrate how to prove that. It's quite simple. Some of these are ancient Vedic techniques. Vedic Ganit. Vedic Ganit is a kind of like the time of the Atlantis, and hypothetically, but they have some really cool techniques because in the ancient days they didn't see the numbers as we see them as 1, 2, 3, 4. The Vedic Ganit people, the ancient people, they saw numbers as perfect squares, so they did not work with natural numbers like how we do. They only identified 1 square, 2 square, 3 square, and so forth. And every other number in between is sum of perfect squares, which is true for any amount of number theory, where any number can be expressed as a sum of squares. And no matter what number you take, eventually even the most basic case, a number could be like, let's say 362 is just a 1 squared plus 1 squared plus 1 squared. But any number can be expressed as a perfect square. So they only worked with perfect squares. That's another one of the ancient techniques. I might make a tutorial video on some of those things. But in here, componendo and dividendo, when we apply this, the top, this plus this will become 2 to the power 2 into e to the power x plus 6 half. And then a minus b, you're going to have the component of 2 e to the power x minus 6. And same thing here. You have 1 plus I e to the power x by 2, 1 minus I e to the power x by 2 will have a similar result, and you're going to land into 2I e to the power x by 2 divided by 2. So now you're looking at e to the power x plus 6 Now you've got the same power on the numerator and denominator. You can combine them as one. This whole thing is half power. And now you're looking at e to the power x over 2. Okay, when you get to this point, now you can square this to get rid of the I. So then you're going to run into an equation which is x minus x e to the power x plus 6 divided by e to the power x minus 6 equals I square e to the power x by 2 squared, so that will become e to the power x components. So now this thing changes into -1. So now we're going to work from here, and we're going to notice that this is a quadratic equation if we substitute e to the power x equals t. This equation simplifies quite easily and turns into a quadratic equation of e to the power x components. So this becomes e to the power x plus 6 equals e to the power 2x. It's e to the power x multiplied and plus 6 e to the power x. So this is the same equation as e to the power 2x plus e to the power, this will go here, so this will become minus 5 e to the power x. So let's make sure we have our sign correct. So e to the power, it will be 5 e to the power x plus 6 equals 0. So e to the power x equals t. This becomes a quadratic equation with the roots of 3 and 2. So e to the power x minus 3 e to the power x minus 2 equals 0. So by factor theorem, we know that e to the power x equals 3 and e to the power x equals 2. So the values are log natural of 3, x equals log natural of 3, and x equals log natural of 2. Now that should be one of the options here, but they don't have log natural 2. Two choices, but they do have log natural 6, because when you add, they say sum. Now if I wasn't reading the question that it's a sum, I'd be like, hey, maybe it's a. But that's not the case. It is looking for the sum of log natural 2 and log natural 3, which is log natural 6. So ln 3 plus ln 2 equals ln 6. So that's that. Now, don't worry if you are familiar with Componendo and Dividendo. There is no other simpler method to solve this without using that little trick, and there's a lot of rational functions, irrational functions that can be solved using Componendo and Dividendo. That's why this technique is there, because there's no other method to solve it easily the amount of time, but it just trivializes the problem. So that was it. Thank you for watching, guys. Bye-bye.